Hello everybody, welcome back to another video, and in this video we'll be looking at the integral of the inverse tangent of x. And we know that in my previous video we looked at the derivative of the inverse tangent of x, and we'll need to use that for today's video, because the key to integrating a singular function in which we don't know how to integrate by itself, we need to look at that as that function multiplied by 1. And the reason why we do that is because when you have a product of two things in an integral, we can use integration by parts. And just a note, the method of the way of integration by parts I'll be using is the DI setup. That is the exact same thing as integration by parts, but just a more visual way of setting it up. So of course, we have the signs here, you have the plus and minus, and those correspond to UV. Minus the integral of v du, this is the minus, and here we choose what to differentiate and what to integrate. So we know how to differentiate the inverse tangent of x, so let's put that here. And of course, we can integrate 1 pretty easily, so let's do that. So the integral of 1 is just x. And here we now need to take the derivative of the inverse tangent of x. So we know that here, that is 1 over 1 plus x squared, which is what we computed in the last video. Now, what we need to do with the DI setup, we take the product of the diagonals, and then, as I mentioned earlier, the product of the row is always an integral. So this right here is an integral. So what we need to do now is we need to see that this is now just multiply everything out. So we have x multiplied by the inverse tangent of x minus the integral. So this is like uv minus the integral of v du. So here we have x multiplied by this expression. So that's just x over 1 plus x squared dx. So what we notice here is that we have a 1 plus x squared on the denominator, and if we take the derivative of that expression, we will end up with a 2x, which is a linear term, and so is the numerator. So why don't we try taking a u sub, because we can see some cancellations happening. So we can set u to be 1 plus x squared, therefore du, taking the derivative of 1 is 0, derivative of x squared, that's our favorite question, that is just the power rule. You can use the power rule, so that is 2x, and then multiply by dx. Now we need to isolate dx here to take our integral to the u world. So we see that now dx, now to do that we divide by 2x on both sides. So dx is du by 2x. So now our integral is, it evaluates 2x multiplied by the inverse tangent of x, and then minus the integral. And what we'll actually do is we'll see that this over 2x is the same thing as 1/2 multiplied by this du by x, and we can take that 1/2 multiple out, as it's just a constant multiple compared with respect to the integration variable. So we have 1/2 multiplied by the integral of, now we have x over, and then our 1 plus x squared is our u, and we have our dx to be du, and we've taken our half multiple out, so we just have du by x. And very, very nicely, we see that this x and this x cancel out. X times 1 over x will just cancel out, and here we are left with x multiplied by the inverse tangent of x minus a half of the integral of 1 over u du. And the integral of 1 over u in the u world is, of course, the natural log of u. That is just an integral that we know because we know the derivative of the natural log of u is 1 over u. So then the integral of the derivative, they will cancel out, and you're just left with 1 over u. So we have now we have x multiplied by the inverse tangent of x minus 1/2 of, and then we have the natural log of, and then let's put the absolute value of u. And this is not done yet, however, because we need to go back to the x world. So let's just put this here. So we finally see that the integral of, and then original thing was the inverse tangent of x dx, that's equal to x multiplied by the inverse tangent of x, and then minus 1/2 of the natural log. And then here, we don't actually need the absolute value, because we see that our u is 1 plus x squared. And we know that 1 plus x squared is always greater than 0, because x squared is always greater than 0, and adding 1 to that will only keep it greater than 0. And of course, that is for the real numbers. Our integral was in the domain of real numbers, so we don't need to account for complex numbers. So here, we don't need the absolute value. We just can put a regular bracket here and see this is the natural log of 1 plus x squared. And here, we can put a plus c because we are done with our integral. So that was the integral of the inverse tangent of x using the derivative of the inverse tangent of x, and a nice trick for integration by parts. So thank you for watching.